Hi there, welcome to my YouTube class. Today we are going to discuss on Kashaf's law based on the DC electricity, how Kashaf's law is applicable and what the law actually is. That is what we are going to study. So Kashaf's law, there are two laws. One is what we call as voltage loop, KVL, and the other one is KCL, current loop. And quite often it is also said as Kashaf's first law and second law. First law particularly refers to KCL, Kashaf's current loop, whereas the second law referred to as Kashaf's voltage loop. So here we started with Kashaf's voltage loop first. We placed three resistors connected end to end, which is we call as series connection, and these resistors are connected with the power supply. So you know that the potential difference, the voltage, is work done per unit charge. So what charge, 1 unit charge, so what work is being done by 1 unit charge to flow through the circuit is known as EMF, and what work is done by this 1 unit charge to flow between 2 points across a resistor is what we call as potential difference. For EMF, it is throughout the circuit. For potential difference, it is just the 2 points in the circuit across any component. So right here, the battery voltage V equals to V1 plus V2 plus V3. Why? Because the energy, the charge gained from the battery, this energy is used when it flows through R1, R2 and R3. Apart from this R1, R2 and R3, no other resistance component is present. So we equated the energy being transferred from the battery same as the energy being used up in the circuit. As you know that energy must follow its conservation rule. So we could write V equals to V1 plus V2 plus V3, and bringing all this in the same side, it is giving us that sigma V, summation of V is 0. So in his second law, KVL law, Kashaf said that the algebraic sum of all the PDs in the circuit is equal to 0. So it is based on the conservation of energy. Here, this is what we call Kashaf's voltage loop and Kashaf's second law as well. It is based on conservation law of energy. Energy gained by the charge from the battery is going to be same as energy dissipated, used up through the various components in the circuit. Nothing more, nothing less. Whatever energy it gained from the battery, that energy has to be used up while flowing through the circuit. So energy per unit charge is the PD voltage, and here we equated V with V1 plus V2 plus V3. There are no resistance, so these V1, V2, V3 combinedly equal to the voltage of the battery, what we call as EMF. All right. Now looking at Kashaf's current loop, here the power supply, the battery, is connected with the resistors, but resistors are now not connected the way it was in Kashaf's voltage loop. It is now connected side by side, what we call as parallel connection, so that the current that is flowing through the circuit is divided. You look at this KVL one, the current remained the same while flowing through R1, R2 and R3. because there was no branching. Right here, when we see the current being delivered from the positive terminal of the battery, it reaches at a junction and it splits up. Because of R1 resistance, some I1 current flows through it. What is left? Left is I minus I1. This much is left. This current reaches to this junction and again it sees there are two branches. It again splits up. Some current I2 is flowing through this R2 resistor, and the rest of the current, which is I minus I1 minus I2. This much current is left out and it now has to flow through this R3 resistance because there is no other branches. So this I minus I1 minus I2, we can consider this to be another variable I3. It is flowing through this R3 resistor. Okay, we'll assign I3 for the R3 resistor later on. So this current I splits up, and whatever is going to in one branch, the left out is moving to the another direction, you know. So when this current I minus I1 minus I2 flows through R3, it joined the current I2 that flew through R2. They join together. What is now going to be the total current? I minus I1. That is joining with I1. That I1 flown through R1. That I1 gets cancelled out. So what is now the total current? I. So look at this. The current I delivered from the positive terminal of the battery is same as the current I entering into the negative terminal of the battery. Nothing more, nothing less. Here it is the Kashaf's current loop. Whatever current is delivered, that current is going to be received. So current leaving the terminal is same as current entering into the terminal. Total current leaving out of a terminal is same as total current entering into the terminal. So here we see that algebraic sum of all the currents is going to be 0. So I here splits into I1, I2 and I3. Let's label this current I3 that flows through the resistor R3. And you understand this I3 is nothing but I minus I1 minus I2. This much current was left out and it did not have any branch to split up once again. So this current, flows through R3. So we summed up this current and we said that these currents are equal to the total current I. This is what we have seen when we analyzing the current in this circuit. So I plus minus I1, that means this I1, I2 and I3 which were in the right hand side, we brought them in the left hand side and we can call them that algebraic sum of currents is 0. When I take the sum, total sum of the current in the circuit, it is going to be 0. So algebraic sum of the current, when the current splits up, when the current goes to the branches, several branches, ultimately they are being divided and joined again. So algebraic sum of all currents here equals to 0. This particular second law, first law or Kashaf's current loop is based on conservation of charge. So two basic principles of physics, conservation of energy, conservation of charge. These two basic principles of physics are being used, considered in these two laws, what we call as Kashaf's first law and second law. You see, the first law is KCL, Kashaf's current loop. The second law is KVL, Kashaf's voltage loop. Okay, one is KVL is based on conservation of energy, KCL is based on conservation of charge. So I hope you understood this, but we need to do some sorts of problems where we can apply KVL and KCL correctly, and we can analyze the circuit problems. Okay, so this is now coming up, how to apply this KVL and KCL together in the question. Okay, sir, thank you for watching this video. Thanks a lot.